physical states of matter. All matters and all physical objects surrounding us are found in one of the following three physical states: solid, liquid, and gas. The food that we eat is an example of the solid physical state, and the water that we drink is an example of a substance that exists at the liquid state. And the air that we breathe is an example of something that exists in the gaseous state. And these three different physical states right here have different properties and characteristics to them. For an example, they have different amount of motion to them, and different spacing between the particle, and different arrangement of the particle, and interaction among the particle. And some of them are compressible versus others are not. And they also have different volume and shape to them as well. So these are some of the important property or characteristic that it worth it for us to do a comparison between these three different physical states. And these are some of the example of a diagram of these three different physical states right here. And now let's describe them to make sure that we are familiar to be able to describe with all of these physical states. First one, with regard to the motion among the particle. So each of this bar right here represent a particle. And so here the gaseous state, the liquid state, and the solid state. When it comes down to motion, motion refers to movement. And the gaseous state have particles have the most movement of all, followed by the liquid state. The particle in the liquid state would be considered to have a medium amount of motion to it. And lastly, the solid, which have the least amount of motion to it. And the type of motion that we will find in the gaseous state involve rotation, so the particle can rotate. It can also move freely and not being bounded by each other, so they move freely of each other, independently of each other, versus the particle in the liquid state. They can also rotate and they can move around. However, they move relative to each other, meaning they cannot move freely, but then they still stick into each other as they move. So they move relative to each other. So in a way, they are sticking together as they move. And in the solid state, with regard to the amount of motion, they have very, very little motion. So they basically no movement at all. The solid state can only move in one particular way, and that is called the vibrational movement. So they simply stay in a fixed position and they do not move around as much. However, they are vibrating. So they do not move except for keep on vibrating in fixed positions. And now let's compare the amount of spacing between this the particle of this different physical state. When it comes down to the spacing in the gaseous state, then the gases have a lot of empty spaces among the particle. And this picture right here doesn't really do justice right here, because it make the gas particle really big, and it make this space right here seem very little. But technically speaking, all of this particle right here are very far apart from each other. So there are a lot of empty spaces. A lot of empty spaces among the gas particle. Versus in the liquid, they must now closer together. And so the gaseous state will have much more spacing between the particle compared to the liquid state. And now, in comparison with the solid state also have the particles that are very close together. And in fact, between the liquid state and the solid state, the liquid and the solid state have about the same amount of spacing between them. Maybe one may be a little bit more than the other, but very, very close together. An example of this is if we were to take a bottle of water and we put it in the freezer to change the water from a liquid into a solid, we would actually see that the bottle would be expanded a little bit. So that tells us that the solid state has actually a bit more volume compared to the liquid state. But this is dependent on the different types of substances. So for the most part, we can consider them to have very, very similar amount of spacing between them. And now as for the arrangement of the particle, in the gaseous state, the particle basically have completely disorder, meaning they move around in any way that they want. There's no arrangement of how the particle should look. So we would call this complete disorder. Versus in the liquid state, we also see complete order as well, because these particles are sticking together and they're still moving around, and they have also disorder to them as well. But between the liquid and the gaseous state, then the liquid would have a little bit more order compared to the complete order that we see in the gaseous state. And now moving on to the solid state, the particles in the solid state are very well ordered. They stay in fixed position. So this have order arrangement of the particle. And the fourth characteristic, the interactions among the particle. When it comes down to the gaseous state, each of these particles right here do not interact with each other. So they move around and they may collide into each other. And other than that collision right there, one particle is not sticking to another gas particle. So basically, there's none. There's no interactions between the particle except during collisions. So none except during collision. Versus in the liquid state, the particles are actually held together quite strongly. So we would actually consider this to have moderate amount of interaction between the particle. And in comparison, in the solid state, this is when the particles are very, very strongly held together. And it's due to this strong interaction right here that make the particle come so close together and make them become basically incompressible because there's no spacing between them. And next, the compressibility. Because gaseous states have a lot of empty space between them, therefore they have very low compressibility, meaning we can take a very large volume and compress them to a very small space. Versus in the liquid state, since the particles are very close together, there's not much empty spaces between them, therefore there's no extra empty space to be compressed, so therefore it is not compressible. And same thing with the solid state, it is not compressible. And lastly, volume and shape. In the gaseous state, it is then said to have indefinite volume and indefinite shape. And the reason for this is as follows. If we were to take a sample of a gas and put it in a container of certain volume or shape to it, then that gas sample would adopt the volume and the shape of that container. But if we were to now open it up and give it a new environment, then it now will occupy the volume of the shape of the new container. So therefore, it has indefinite volume and indefinite shape. Versus in the liquid, a liquid have definite volume but indefinite shape. the volume of a liquid would always be the same. But if we were to now put it in a cup, it will adopt the shape of the cups. Versus if we put this in a beaker, it will adopt the shape of the beaker. So therefore, indefinite shape. But the volume should always be the same. And lastly, with the solid state have definite volume and definite shape. Its shape would always remain constant. So if we were to take a solid, something that we can touch, then it always remains in that shapes. So these are some of the comparisons among these different properties and characteristics between the solid, the liquid, and the gas. And lastly, by changing the temperature and the compression, we can actually cause state change. So state change refers to the change when one physical state changes into another. If we were to take a gaseous state, it's possible for us to actually convert this into the liquid state. And we can also take a liquid state and convert this into the gaseous state as well. And in the opposite direction, we can take the gaseous and the solid state. We can take a solid state and convert that into the liquid state. And that's an example when ice melts into water. And we can also take a liquid state and now change that into the gaseous state as well. So all of this are called state change. And this state change right here can be induced or can be controlled by changing the temperature and the compression. If we were to have a gaseous state, by cooling this or compressing on the volume of the container, by pushing all the particles to come close together, we will be able to change this gas state into the liquid state. And the opposite of this, if we were to have a liquid state and we heat it up or we reduce the pressure, then that's when we can change that into the gaseous state. So going from liquid to the gas can be done by adding heat or reducing the pressure. And similarly, if we were to have a liquid, by cooling this, we'll be able to change this into a solid state. Now we cannot compress that into a solid state. We can only cool a liquid into a solid state, but not compress it, because liquid is incompressible. And in the opposite direction, if we were to have a solid state and we add heat, we'll be able to change that into the liquid state. Very much what happened when we take an ice cube, and put it at room temperature to warm it up. So please try the following example right here involving the different physical state of matter.